Okay, so in the previous video we were calculating the binding energy of the MgO system by varying the system size, and in this way we wanted to adjust to choose the minimal system size that is appropriate for our purposes. The problem, however, was that when all the points seems reasonable, I mean, here we have a very low energy due to interaction between the molecule and its image, and it could stabilize, except the problem is that when we choose the system 4x4, then we have this strange peak here. And the reason is that there is a mistake. I mean, a small error. The problem is that because we assuming that the resulting binding energy should be unchanged eventually, that means that we need to calculate the system in very, very same configurations in every case. As I said before, if we would, for example, relax the surface, the small atom variation could result in the energy changes, and the tendency wouldn't be so clear. And in each case, the N-heptane was placed so the 4 carbon atoms were closer to the surface than the remaining 3. Like here, also like here, but not like here. But not like here. Basically, this molecule is inverted. And that resulted in a different binding energy. Well, how to overcome this problem? Well, we need to flip it. Okay, so we'll flip this molecule. So now we have proper orientation, and we'll repeat the calculation by first optimizing the geometry. And as you see, the energy is different. Before, it was 30 something, which was pretty strange because it obviously was very, very different from the remaining energies. Now it seems a little closer. Okay. As before, we'll create a separate folder for our molecule for the single point energy calculations. We'll copy our system here. And as again, I'll calculate the single point energy of my system, of my molecule. There we go. And as again, I will copy those energies into my previous Excel file. Don't make a mistake. Okay, as again, I'm going to change the points into commas, and now it looks much better. It looks much better. And as you can see, you see the clear tendency of flattening out the binding energy. Now, the binding energy starting from 3 by 3 is varying. We can also calculate, for example, the differences. Okay. So in the case if we want to have accuracy of the binding energy below 0.2, this system size is okay. If we want to have the accuracy between below 0.1, this one is okay, and so on. So for the purpose of our calculations, as in the publication, we'll choose the system 4 by 4. Okay, and that concludes this video.